So hello to everyone. Welcome to another session here with us at Mathematics Resource Center. And today we'll be looking at circle theorem. All right. Most of our questions are taken from Carbon Math. That is an excellent site. So you need to go over and check out Carbon Math. It has questions, um, testing fluency, test problem solving, good for teachers as well as it is good for students as it also provides solutions. They have a class from primary straight up to A level, I believe. So if you don't know about Carbon Maths, go on over and check out Carbon Math. And guess what? They also have the videos that will explain the concept that the worksheets are covering. So go on over and check out Carbon Math. It is an excellent platform. So without any further ado, we are going to go into circle theory. And we're going to try and work as many questions as possible today. Right?
Okay, today's goes our second theorem questions. I did print and paste them in a book because I wanted them for another purpose after this. All right, so find the missing angle labeled in the circle below. So here, we're looking for this angle here, x, right? We know that here is 38, and this angle over here is also 38 because they're angle formed in the same segment, right? So you got to know your circle theorem rules. You got to know from the basic. And what I'm doing today is to just go through questions, right? I'm not teaching the concept because you would need to know the concept already. What I'm actually doing is to just go from work out the questions. All right. So if you don't know the concept, go on check out. I don't have any video teaching the concept, but you can Google, YouTube it, learn the concept, and then you can look at these questions and do your practice from them. So here we're finding the value of x. So I'm going to write x equal, and I know that this bit here is 38 degrees because it's angle formed in the same segment or by the same chord. So I know that this is 38 degrees. And I also know that this angle here is a right angle. I might need to get some other color pens. And that's a right angle. So because that is a right angle, how I know that it is a right, let me look carefully. Hold on. No. Right angle, no. No. Let me check. Oh, yes, I'm correct. Okay. Yes, I am correct. Okay. So yes, it's a right angle. Let me get another pen, some colors. All right. So we know that that's the right angle here because it is formed by this diameter. So as I tell my students that anytime you see a diameter, right, the center is O, and we see a diameter, always look out for the right angles. So this diameter, we know that this is a right angle. This diameter here, same, just the same, we know that this is a right angle. This diameter, we know that this is a right angle. And this diameter, same diameter there, we know that that is a right angle. So anytime we see a right angle, we know that we can look out for anytime we see a diameter, we know that we can look out for a right angle, triangle. Good. So that bit, so that bit here is 38 degrees. And if that is a right angle triangle, then that means x is 90 degrees. Subtract 38 degrees, which equals to, so that's 50 minus 40. So 90 minus 40 leave us with 50. So that's 52 degrees. And we need, not want, need to put our reason. So the reason for this is that, one, we know that the angle formed by The angle formed, so the first thing is that we went from the fact that the angle formed by a diameter, or the angle formed in a semicircle, is 90 degrees. All right, so the angle, use a symbol for angle, formed in a semicircle is 90 degrees. Good. And then the next bit now is that we know that this was 38 degrees. All right. So let me see if I can bring this down a bit. So it's all right. All right, so we know that this is 38 degrees. How did we know that it's 38 degrees? Because why my camera seems so blurry. Let me see if I get. All right, let's see if we clean this bit. That looks a little better. Right. Oh, there we go. All right, so we know that this here is 38 degrees. All right, how did we know that it's 38 degrees? Okay. So how did we know that it's 38 degrees? These are angles formed in the same segment. So angles formed in semicircle is 90 degrees. Angles formed in same segment are equal. And there goes my pen ink. In same segment are equal. Okay, I'm just gonna use a green pen. All right, so are equal. And the last bit is we know that, okay, so that's 90 and angles. Yeah, so those are the two things that we use to get the answer. All right, let's go to this bit now. So they say that here's 40 and that is X, right? So we need to figure out the value of X. What we do know is that we see, maybe I need to bring this up a bit so that it stops from blurring when I'm writing, because it's a bit close, so it blurs out each time. Okay, so what we do know is that here, this is 40, that is here, 40 degrees, and this is the letter variable X. So they're saying, we see two arrows here, one there, those two arrows. So that tells us those two lines are parallel to each other. And because those two lines are parallel to each other, we can also figure out that, okay, this is parallel, then that means this angle 40 is the same as this angle here. So this is 40, right? And that is also 40. So we call them Z angles, right? So we know that. So we're going to do X now. X equal, so we know that this is 40 degrees. And this here, these two angles are formed by the same chord here, right? So that chord formed them. Good, form them into, so they're formed by that chord. Both of them formed by the chord. So we know that that angle is 40 degrees as well. Hence, we can say how we came by our 40. So we use Z angles, and we also use angles in the same segments are equal. If you have any other way of writing this, feel free to comment, say how you would write this down, and any other approach, feel free to comment as well, and just share your idea of how to go about solving these questions. All right. We also have a Facebook group, mathematics, I think it's CSEC class. I'm not sure. I don't quite remember exactly, but we do have a Facebook group. I will definitely put the link below when I finish. All right, so we have A, B, C, D, and E are points on the circumference of a circle. Find the size of the angle Y, given reason for your answer. So this bit here is 36. I'm just going to write it here. This is 112. So right there is 112. It's a bit small. So I'm just going to write it here, 112. Doesn't make much of a difference. And this here, they have Y degrees, and up here they have X degrees. All right. So when we look at it, they're asking us for the value of Y, right? They tell us that here's 112 and there's 36. We are seeing a triangle here, and the triangle is A, this triangle A. Well, let's label the center O. So AEO. All right, so in that triangle, we know that one angle is 36 degrees and one is 112, right? So that allows us to find this angle. And if we find that angle, then we can easily well find the value of Y. All right, so to find the value of Y, we are going to say 180 degrees minus the sum of the other two angles in this triangle. So that's 112 degrees plus 36 degrees. So that is 180 minus 112 plus 36, that is 148 degrees, which leaves us with 32. 32, is it? 32 degrees. Good. So we now have 32 degrees. How did we come by the 32 degrees to say that that is the value of Y? Okay, we can find this angle here at E, OEA. And if we find the angle here at OEA using angles in a triangle, adds up to 180 degrees. So we use that bit, and then we can also move on to say that angles in the same segments are equal. So these two are in the same segment, so they are equal. So angles in the same segment are equal. All right, so we know that bit. The next bit is we're asked to find X, that's the angle up here. And I want you to look to see what you can pick up from the diagram. This diagram. Hello? Me call you back. All right, so this diagram here, let's see if what we can pick up from here. All right, so that diagram. All right, so what type of diagram do we see? The point D touching there, the circumference, the point C touching the circumference, that's 2 points, the point B touching the circumference, 3 points, and the point A touching the circumference. What type of diagram are we seeing there? All right, sorry about that. All right, so what type of diagram are we seeing? We're supposed to be seeing a cyclic quadrilateral. Good, so since we're seeing a cyclic quadrilateral, we know that opposite angles in a cyclic quadrilateral are supplementary. So if here is 32 degrees, supplementary means that they add up to 180 degrees. So if here is 32 degrees, which is this part down there, then the value of X is just going to be 180 degrees minus 32 degrees. Therefore, X equal 40 from that, so it's 148 degrees. Good. And we know that angles in a cyclic, you must have your reason, without a doubt. You ought to have your reason, because if you don't have your reason, guess what's going to happen? You're going to lose a mark. All right, and that stands between you getting the highest grade. 1 mark can deter you from getting that grade that you want to get. So angles in a cyclic quadrilateral are supplementary. Good. So we have that bit. And yeah, that's it. So we move on to some other questions. All right, so these are some other easy ones. This here, we look at it, they're formed by the same chord. So I know that that's 24 degrees. You write in your reason. Angles in the same segments are equal. Same here. I know that x equal 50 degrees. You must write in your reason, write in your reason. This here, they are all formed by the same chord here. So I know that B is definitely, you can turn it if that makes you see it better. So we know that B is 37 degrees, write in your reason. A is 37 degrees, write in your reason. If we turn this upside down, we might see it better. So there goes this one turned upside down. So we know that this was saying 52. So that means X is also 52 because they're formed by the same chord. All right. So X equal 52 degrees. We come down here and we do this one first. The angle at the center is twice the angle on the circumference. So we know that A therefore equals to 110 degrees divided by 2. A equal to 55 degrees. Angle at center is twice angle on circumference. And we can use the same rule to say that B is also 55 degrees, or we could say that angle formed by the same chord or forming the same segment are equal, so B is definitely 55 degrees. So you go ahead and you write down that reason as well. All right, so we go down to you two here. Find the missing angle labeled in the circle below. We know that here is 47. If the angle at the center is twice the angle on the circumference, then that makes it that the angle on the circumference is half the angle at the center. So if that's 47, then B is twice that. So it's 47 degrees times 2, which gives us 94, I think, 94 degrees. Good. And if it is angle on the circumference is half angle at circumference at center, or angle at center is twice angle on the circumference. All right, around here we have these bits. They are quite similar to what we just did. I'm trying to see if I find any question that is worth just pushing you to do. So this bit here, let's look at these. That takes in a bit of variable. So here is 2x, that's x. And they want us to find the value of x. We know that here is 90 degrees because we see the center pointed out to us. And the center, there, the line going through the center means that this bit here is a right angle. Given that it is a right angle, we know that what's left in that triangle must be 90 degrees. So let's just do that bit. So I'm going to do U right here. So I therefore know that for U, let's see if I bring this down a bit. So we know that for U, it is going to be x plus 2x equals 90 degrees. X plus 2x equals 90 degrees. So that is going to be 3x equals 90 degrees. Divide both sides by 3. X equals 3 into 6 into 9. That is 3x equals 30 degrees. All right. And the rule for that is the fact that we know for the question is that this line here is the diameter, which makes this angle here 90 degrees. That means all that left in this triangle is 90 degrees. So we add these two, they must equal to 90 degrees. We create an equation and find the value of x. So this angle is 30 degrees and 2x would be 60 degrees. Good. All right, so we do this one. X plus 32 is that one. Same approach. We know that this angle here is 90 degrees because it's formed by the diameter. So we're going to do x plus 32 plus 3x minus 6 equals 90 degrees. All right, so we have 4x plus 20, what is that now, 28? No, 26, because 4 from 30 is 6, so 26 equals 90 degrees. So that means 4x equal, what is 90 degrees minus 26? So 90 minus 30 is 60, so that's 64. And then we divide both sides by 64. So that is x equal 4 into 4, 1, 4 into 6, 1, and 4 into 24, 4, 6 is 24. The x equals 16. We are asked to put in the angles now. It is going to be for this one, 3 times 16 minus 6. I believe 3 times 16 is 48 because 3 times 15 is 45 and plus 3, so that's 48. 48 minus 6 will leave us with 42. So that's this angle here is 42 degrees. And then this one would be 16 plus 32. So that's 8. That's 8, 48. So 16 plus 32 degrees equals 48 degrees. All right, so that's it for that one. This is a cyclic quadrilateral. So for this one, you just do 180 degrees, subtract 68 degrees. For this one, you do the same 180 degrees, subtract 68 degrees. All right. The others, they should be quite simple. This is 33 degrees because these two are formed by the same chord. These two, this angle and this angle are equal because if you look here, this is a radius and the length of all radius in a circle are the same. And this is a radius 2 because you see the center there and they're coming from the center, which makes this triangle that I'm highlighting now an isosceles triangle. Therefore, the angle here and the angle here is the same. So if I know that this is 33 coming from over here, then y also equal 33 degrees. And if that's 33 degrees, then x equal 180 minus the sum of these two angles, 33 degrees times 2, because we have two 33 degrees, which equals to 180 minus 66, which means that 66 from 70 leave us with 10, 100 and 10, 114, I believe, 66, 70, 80. Good. So that's it, and you put your reason in. I'm not going to be writing out all of those reasons. So you ought to put your reason in. Remember that. Stands between you getting the perfect score and not getting the perfect score. All right, I'm going to zoom out a bit now. All right, how we're looking. All right, we're almost there. All right. All right, so there we have this bit now. So in diagram, O is the center of the circle, AOC is straight line. So AOC is a straight line, which that is a diameter. So from I see that diameter, I start thinking, okay, there's a right angle somewhere. That means right here is a right angle, and right there is a right angle. That's the first thing I start thinking. All right, the next thing that I start thinking about now is that they say, oh, this is 24 degrees. And okay, if that's 24 degrees, what are they asking me for? They say ABO, O is 42, so I know that bit. Find the angle C. Let's see, yeah, CAD. So they want me to find the angle right here. All right, what do I know about that bit over there? Do I have a right angle there? I have a right angle here, I have a right angle there. What else do I know about that bit? Do I know anything else? No? Is there anything else that I know about that bit? No. All right, but when we look at it, this triangle is formed by 2 radius. So that means if this is 42, then this is also 42 degrees because it's an isosceles triangle. So the angle CAD equals 42 degrees. All right, and it's formed by isosceles triangle. Put in your reason. All right, find the size of angle ACD. All right, so the angle ACD is going to be quite simple for this one as well. So this one is the angle here they're asking for. And what we do is we know that this, let me put it in green, is a right angle triangle. Which means that, so let me put that in green, so you can see the right angle triangle. If this is 42 degrees here, and here is 90, then 90 is shared between these two, right? So I know that this now is going to be 90 degrees ACD equal 90 degrees minus 42 degrees. So that leaves me with 45 plus 3, 48 degrees. Put in your reason. And the last one, find the size of angle BCD. BCD. Okay, so we asked to find BCD, which is all of this angle here. And we realize that this is a cyclic quadrilateral. So if these two is here, we add those up, and that should give us BCD. All right, so BCD therefore equals to 180 degrees minus the sum of these two, because opposite angles, let me highlight it with this color. Opposite angles in a cyclic quadrilateral are equal. So these two, not equal, are supplementary. So this is a cyclic quadrilateral because all the points, 4 points touches the circumference. Good. So these two, angle BAD and angle BCD, are supplementary. So I'm going to add those to 42 and 24. So that is 180 degrees minus 42 degrees plus 24 degrees. And that equals 180 degrees minus 42 degrees plus 24. That is 66 degrees. Which therefore leave me with 100 and is that 14 degrees. So I take 66 from 7 to leave me with 4, and 10 will be left off of the 80. Yeah. And you put your reason in again, whatever you use to get there. Okay. I feel as if I'm running out of breath. I'm here thinking, wonder if I have COVID because I have short breath. I maybe just need some water. Yes, let's continue. Q and R are points on the circle center O. PQ and PR are tangents to the circle. One thing I want you to know about tangents to the circle is that one, they are the same in terms of length from the same point to the circumference. The length here and the length here are equal. So if here is 5 centimeters, just if, then here's also 5 centimeters. So I want you to know that bit. The next thing I want you to know is that I know. What else I needed to know? So they say work out the size of angle POR, but I didn't even draw anything there. So we know that OR forms a 90 degrees. I don't know why this isn't drawn properly. And OQ forms a 90 degrees. And they want us to work out POR. All right, so it's basically split. Normally the question would become full. I don't know why this one isn't. All right, so normally it comes full. So we know that OR is a POR. Okay, good. So we know that OR is 90 degrees and OQ, the line there, would form a 90 degrees as well. And we know that this is therefore, what would I say now? This side is equal to this side. So this line here, OP, would split the angle here into equal parts. All right, so here we have 44 degrees. And if this is 90, if we look at it, make sure you're seeing that. If you look at this diagram, you're seeing a quadrilateral. So if I've taken out 90 over here and taken out 90 here, then all that left to be shared is 180 degrees. So the angle right here at O, that is QOR, is going to be 180 degrees. So 180 degrees minus 44 degrees, which leave us with, what am I looking for? What does that leave me with? 136 degrees. Good. And I'm going to share that 136 degrees into 2. So that leaves me with 50, 65, 68. 68 degrees. So I split the 100, got 50. Split the 30, got 15. So that makes 65. And split the 6, got 3. So that makes 68. All right, so that's the way that you can do your math mentally when it comes on to division, like especially an even number like this, or any number as a matter of fact. So we were trying to find the angle POR. POR. Good. So we're done to this one now, and I'm out of breath. I think I need to take a break. All right, so since I'm taking a break, let me go over to see if there's anyone joining us on YouTube presently and just what you're saying. And if I can support you. All right, okay, so no one is. All right, hello, I see. Okay, 3 persons like. All right, so no one is viewing at this point. Oh, my video paused, okay. All right. All right, so no one is viewing at this point. So we're gonna go back to our lesson. All right, so we're back at our lesson. And we have this one. DAE is a tangent to a circle right on the sides of the angle ABC. ABC. So what we do know is that the angle formed between a chord and the tangent is equal to the angle formed in the alternate segment by the same chord. So this angle here that forms between the chord and the tangent is equal to the angle formed by the same chord in the alternate segment. So that means that angle ABC equals 61 degrees. Good. ABC, ABC. Yeah. And you put down your reason as I just give it to you. All right. So let's see what we have here. AOB is a straight line. ABC are points on the circumference of a circle. Center O, AC is a tangent to the circle. Work out the size of Y. All right, let's put in what we know. I will start off with what I know. I know that here is 90 degrees because the tangent and the radius meets at 90 degrees. I know that if this is Y, then this is also Y. And I know that over this side is 90 degrees as well. What else do I know? I know that if this is 46 and this is 90, then I can find the angle here. So that would be 90 degrees minus 46 degrees. And that is going to be 44 degrees. So I know that here is 44 degrees. Good. And I know that these are angles on a straight line, which means that this here, this angle right here on this bit over here, and this bit over here adds up to 180 degrees. So I can say 180 degrees minus 44 degrees, which leaves me with 4 to leave us with 36, so 136 degrees. So here is 136 degrees. I also know now that these two, in this triangle, it must add to 180 degrees. So these bits, so if this is 136 and these add up to 44, so you can do the 180 minus the 136 to prove that, but no point in doing that. All right, so we know that that is 44 degrees divided by 2. So y therefore equals 44 degrees divided by 2, which equals to 22 degrees. All right, so a lot of rules to take into consideration. One, this is 90, which means that this 2 add up to 90. This is 136 because angles on a straight line. And then the isosceles triangle. All right, so that's it for that one. And here we go with another one. How much more do I have? Oh, I'm tired. Okay, let's see if we do this one. Work out the size of angle QRS. All right, so the angles that they spoke about up here is in the triangle, is in the diagram. And we can put that bit in. Or do we know? I'm seeing a cyclic quadrilateral. I'm seeing 35 degrees here. That's an angle formed between a tangent and a chord, which means that the angle formed in the alternate segments is going to be 35 as well by the same chord. So I know that here is 35 degrees. Good. I can see that these two lines, this line here, it has an arrow on it, and this one here has an arrow on it, which tells me that these two lines are parallel. That means the angle here, this is Z angle. So if the angle is 35 degrees and the angle here is also 35 degrees. Good. So I know those bits. I also know that opposite angles in a cyclic quadrilateral, because this point touches the circumference, that point touches the circumference, that point touches the circumference, that point touches the circumference, and I'm looking at a quadrilateral there. I know that opposite angles in a cyclic quadrilateral are supplementary, which means that these two angles are supplementary. They add up to 180 degrees. So I can just go and write angle QRS. Oh, I'm doing angle RQS first. So I'm just going to go ahead and write. So I'm doing angle QRS first. So that is going to be angle RQS first. So RQS equals to 180 degrees minus, so I know that all of these angles, this bit and this bit adds up to 180. So it's minus 35 degrees plus 35 degrees plus 80 degrees. And that would give me 150, which leaves me with 180 minus 30, 180 minus 150 degrees, which leaves me with 30 degrees. Did you put your reason? I think this is the last one I'm doing. All right, next time I do some more. All right, so work out the size of angle QRS. QRS. So if this is 30 degrees, then I'm looking at a triangle here, which means that I can just say QRS is 180 degrees minus 30 degrees plus 35 degrees, which gives us 65 degrees. 65 from 70 leaves me with 5 and 10, 115 degrees. There you have it. All right, so that brings us to the end of our session here today. And I hope that the solutions were helpful. And I hope that, yeah, I didn't go too fast, but if I did, just pause the video, watch it again and again and again and again. And remember that you can't do what I just did by leaving out your reasons. You've got to put your reasons in. All right, I didn't leave them out deliberately. I just wanted you to do some work on your own as well. So go ahead and put in all the reason and make sure that you practice. Practice don't make perfect, but practice makes permanent. All right, so practice, 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 practice. God bless you all. See you again next time. Bye bye.